Welcome to my presentation today. I am Julius Dada. My presentation today is on the calculation of distances along the latitudes. Welcome. Radius of any line of latitude parallel to the equator is always given by r is equals to r cos theta. R cos theta, where r is the radius of the earth and theta is the latitude. From my previous presentation, from definition, we agreed that the radius of a small circle is always given by the radius of the earth multiplied by the cosine theta, where theta is the latitude and r is the radius of the earth. Theta is the angle north or south of the equator. Note that when the radius is r, an arc of 60 nautical miles subtend an angle of 1 degree at the center of the earth. At the center of the earth. Therefore, when r small is the radius and angle at the center is 1 degree, the arc length is denoted by r over capital R times 60 nautical miles. It follows that 1 degree is subtended by r cos theta all over r times 60 nautical miles. We know from our definition that r is always equal to r cos theta. Therefore, where we have r, we substitute r cos theta. And then r will cancel out, so that we'll have 60 cos theta nautical miles. Along the parallel of latitude, an angle of 1 degree will be subtended by 60 cos theta nautical miles, where theta is the latitude. Note, small letter r represents the radius of a small circle, capital R represents the radius of the great circle of the earth, where theta is the latitude. For more information, check in my previous presentation in the description below. When you have 1 degree equivalent to r equivalent to 60 nautical miles, then when you have 1 degree equivalent to radius of a small circle, it will be equivalent to r all over radius of the earth times 60 nautical miles. Substituting r with r cos theta, then you will have r cos theta over r times 60 nautical miles. This will cancel out. Then you have 60 cos theta nautical miles. In general, if the angle at the center of the circle of latitude, theta degrees, is alpha, if the angle at the center of the circle of latitude is alpha, instead of 1 degree, then the arc length will be denoted by will be denoted by 60 times alpha cosine theta into of minus. Alternatively, we can use a sketch diagram of the growth and we calculate the arc length KL in Newton-meters and in kilometers. Our KL is equals to alpha all over 360 times 2 pi r. From our definition, we know that r is equals to r cos theta. Therefore, it will follow that KL, arc length KL, will be equals to 360 while alpha by 360 times 2 pi r cos theta. But from our definition, 2 pi r times 1 degrees all over 360 is equal to 60 meter/miles. Substituting 2 pi r over 360, 2 pi r over 360 as 60 Newton-miles, we get our answer as 60 alpha cos theta Newton-miles. 2 pi r over 360 times alpha cos theta, this is distance in kilometers. Or 60 alpha cos theta, this is distance in Newton-miles. We have an example where he has to calculate the distance allowed the latitude 60 degrees north. And we have to take pi as 22 over 7 and radius as 6 degree 70. The distance allowed the latitude, we are being asked to get the circumference of that small circle. And the circumference is already given by 2 pi r. We know our r is equals to r cos theta from our definition. So the arc length, the circumference of this small circle will be given by 2 times 22 over 7, substituting the pi, times our radius, which is 6370, times the cosine of theta, which is 60 degrees. We calculate, we get that the cosine of 60 is 0.5. Therefore, it will form that 2 times 22 over 7 times 6370 times the cosine of 60 is 0.5. Therefore, the distance gives us 20,020 kilometers. This is now the distance allowed the latitude of 60 degrees. Our next example, we asked to find given the latitude and longitude of two stations A and B, 47 degrees north, 25 degrees east, and 47 degrees north, 70 degrees east. We asked to calculate the distance in Newton-miles between A and B along latitude 47 degrees. Distance in Newton-miles is given by 60 alpha cos theta. Our alpha is the angle subtended by the arc length AB, which will be given by the difference in longitude. That will be 70 degrees east minus 25 degrees east. So it will be 70 degrees east minus 25 degrees east, which is equals to 45 degrees. So our alpha is 45 degrees. So alpha is equals to 45 degrees. That is the angle that is subtended by the arc length AB at the center of this small circle. Our theta is 47 degrees. Therefore, the distance will be equal to 60 times 45 times the cosine of 47 degrees. The cosine of 47 degrees is equals to 0.6820. Therefore, it will fall 60 times 45 times 0.6820. And therefore, finally, the distance will be 1841.4 meters of mass. Turning on to the calculation of shortest distance between 2 points on the Earth's surface. We will consider this example. A and B are 2 points on the latitude 70 degrees north. Their longitudes are 62 degrees west and 118 degrees east, respectively. Take pi as 22/7 and the radius of the Earth as 6370 kilometers. Find the distance from A to B, Roman 1 along a parallel of latitude, Roman 2 along a great circle. We have a rough sketch here of our graph that will help us to get the solution of part 1, Roman 1 and Roman 2. We are given that point B is 118 degrees east of the Greenwich meridian. The Greenwich meridian is 0 degrees. Point B is 118 degrees east of the Greenwich meridian, while point A is 62 degrees west of the Greenwich meridian. Now we have to find the area, find the distance along the latitude 70 degrees north. So we are supposed to get the arc length AB. And arc length AB is given by arc length AB is given by 2 pi r argot theta all over 360 degrees. We know from a definition r is equals to r cos theta, where r is the radius of the small circle and capital R is the radius of the Earth. Therefore, our arc length AB will be given by 2 pi r cos 70 all over 360 multiplied by our alpha, and our alpha will be this angle between the two longitudes, which is 62 plus 118, which is equal to 180 degrees. AB equals to 180 all over 360 times 2 times 22 all over 7 times our radius of the Earth 6370 times the cosine of 70, which is 0.3420. This gives me 6846.84 kilometers. In nautical miles, the distance is 60 times alpha cosine of theta, which is equal to 60 times 180 times 0.3420 which is equals to 3693.6 nautical miles. This is the distance along the parallel of latitude of the anchoring AB in kilometers and in nautical miles. Our alpha is always the angle subtended at the center of the small circle by the arc AB, where theta is the latitude. So in our case, theta is 70 degrees, and our alpha is this angle that is subtended by the arc AB, which is equal to 180 degrees. Note that alpha is 180 degrees, which means that the 2 points A and B lie along a great circle that passes through the North Pole. Note the difference in latitude, that is, angle alpha is 180 degrees. Hence, A and B lie on the same meridian of a great circle passing through the North Pole. In our sketch diagram, we have our anchoring A and B, which is a meridian of a great circle. The angle here is 70 degrees because we have this AB, which is parallel to the equator. The alternate angles are equal. So this one is 70 degrees, this one is also 70 degrees. And because the horizontal line, we have the sum of the angle of the horizontal line is 180. If this one is 70 and this one is 70, then what remains here is 40 degrees. Our anchoring A and B subtend an angle of 40 degrees at the center. Therefore, our anchoring A and B will be given by 40 all over 360 times 2 times 5, which is 22 over 7, times the radius, which is 6370, the radius of the arm. This will give us 4,448.9 kilometers. In nautical miles, when you are doing the great circle, it is always 60 times theta nautical miles. So this follows, it will be 60 times 40, which is given as 24 nautical miles. Note that angle theta is the angle subtended by the anchoring A and B at the center of the earth. Therefore, we use the radius of the earth and then the angle at the center of the earth, which is 40 degrees, to get 2400 nautical miles. Note the difference along a great circle between any two given points on the earth's surface is the shortest possible distance. Since the earth takes 24 hours to make one revolution, the speed of rotation is therefore 360 degrees divided by 24 hours, which is equals to 15 degrees for every 1 hour. The earth will rotate 15 degrees for every 1 hour. All 15 divided by 1 hour is 60 minutes. So 15 divided by 60, you get 1 over 4, which means a rotation of 1 degree in 4 minutes. So for every 1 degree that the earth rotates, it takes 4 minutes. This means for any 1 degree change in longitude, there is a corresponding change in time of 4 minutes. Or there is a difference of 1 hour between two meridians, which are 15 degrees apart. All places on the same meridian have the same local time. Local time at Greenwich is called Greenwich Mean Time Meridian. Greenwich Mean Time. Local time at Greenwich is called Greenwich Mean Time, or what we call GMT. All meridians to the east of the Greenwich Mean Time have sunrise before that meridian, and their local time are ahead of the Greenwich meridian. Since the Earth rotates from west to east, any point P is ahead in time of another point Q if P is east of Q on the Earth's surface. The world has 24 time zones, each of 15 degrees of longitude. This facilitates the use of the same standard time within a given zone. From our sketch diagram, we can see that the Earth is rotating this direction west to east. In that case, P will have local time ahead of Q. And Q and K, because these 2 points are on the same meridian, they are on the same time zone. All the 3 points P, Q, and K are ahead in local time of the GMT. Example, you are asked to find the local time of Nairobi, whose position is 1 degree south, that's 7 degrees east, when the local time of Madeira, whose position is 4 degrees north, 42 degrees east, is 3 p.m. Solution. We need to get the difference in longitude. Madeira is east of Nairobi, so the difference in longitude will be will be 42 minus 37, which is 5 degrees. The difference is 5 degrees. For every 1 degree in difference, the Earth takes 4 minutes. Therefore, it will be 5 times 4, which gives us 20 minutes. We have 20 minutes difference in the 2 towns. If we assume that the 2 towns are P and Q, Madeira will take the position of P and Nairobi will take the position of Q. Madeira is ahead in time because it is east of Nairobi. At Madeira we have 3 p.m. Therefore, for the local time in Nairobi will be 3 p.m. We subtract the 20 minutes to get the local time of Nairobi, which will be 2:40 p.m. We'll get the local time of Madeira, which is 3 p.m. We subtract 20 minutes to give us 2:40 p.m. as the local time of Nairobi. One unit command per hour is called knot. An example here, we are given an aircraft reached Nairobi, which is 1 degrees 15 minutes south, that is 6 degrees 49 minutes east at 0900 hours, and flies due west. At 1900 hours, the plane is above town A, which is 1 degrees 15 minutes south, 0 degrees 49 minutes east. We are asked to find the speed of the plane in kilometers per hour and in knots, that is nautical miles per hour. We have to take the pi as 22/7 and the radius as 70 kilometers. We need a rough sketch of the globe to help us to get a rough idea of where the town A is and Nairobi is. N represents Nairobi, and then A represents the town A. We need the difference in longitude to get alpha that will help us to get the acronym AN. We need alpha by subtracting. We subtract 49 degrees east to give us 36 degrees. So alpha is 36 degrees. Now we can get the acronym AN. The acronym AN will be given by alpha all over 360 multiplied by 2 pi r. This is our r, the radius of the small circle. So we need the acronym to be alpha over 360 times 2 pi r. We know from definition that the radius of a small circle is equal to r cos theta, where theta is the latitude, 1 degree, 15 degrees south, and r is the radius of the earth. So the acronym AN will be alpha, which is 36, all over 360, multiplied by 2 times 22 over 7 times 6370 times cosine of 1 degree, 15 minutes. Acronym AN is equal to 36 over 360 times 2 times 22 over 7 times 6370 times the cosine of 1 degree, 15 minutes. 15 minutes is equal to 15 over 60 over degree, which is equal to 0.25 degrees. Therefore, we're looking for the cosine of 1.25 degrees, which is equal to 0.9998. So to follow here, that will have AN is equal to 36 over 360 times 2 times 22 over 7 times 6370 times 0.9998, which eventually will give us 4003.2 kilometers. Now having the distance as 4003.2 kilometers, we can get the speed in kilometers per hour. But first of all, getting the difference in time to give us hours. So we have 1900 minus 0900 to give us 10 hours. So speed in kilometers per hour will be given by 4 divided by 10 hours. Therefore, the speed will be 400.32 kilometers per hour. That's the speed in kilometers per hour. We need now to calculate the distance in nautical miles. Which will be given by 60 times alpha cosine of theta. Our alpha is 36 and our theta is 1 degree 15 minutes, and the cosine of theta, we have it here as 0.9998. .59.6 nautical miles. Therefore, the speed in knots. Therefore, the speed in knots will be 259.6 all over 10, which is 215.96 knots.